So basically, let's learn what is scikit-learn. Okay, so it's a powerful, easy to use library built on NumPy and Matplotlib and SciPy. Okay, so what does it offer? It offers classification. For example, the SVM, that is a support vector machine, I believe, and the random forest. Okay, it also offers regression, which is like the linear and logistic models, the gradient boosting and all the stuff. It also gets clustering, in that we have, for example, the k-means, db scan and all those stuff. Okay, so why is it so famous? It has clean and consistent API. So we know that most of them have these things: the fit, predict and transform, right? And the latest version is 1.7.0. Okay, oh, which was published very recently, which was like last month, June 5, 2025. Nice. So what are its core features? Its core features are pre-processing, which is like scaling, encoding and normalization, and model selection, which is like train, test, cross validation, grid search and all those stuff. It pipelines, for example, we can do chain transformations, and it supports for classification, regression, clustering, which we have just seen. So how do we do that? We import a model. For example, we import a model from random forest classifier. So like that, you can import it from anywhere in all the other models which you have seen just above. Right, in that again we have like the random state equal to 0, so you can put whatever parameter you want over here. The main thing is again x train and y train, or x test and y test. And as I said, it's like fit and what is the other one? Fit, predict and transform. Okay, so over here it's fit. So you can after that you have to make predictions, right? So whatever you have put this x underscore test, right? So whatever you will be putting underscore x underscore test, you will be predicting that. The CLF is the classification model. Okay, this classification is called as CLF, right? Now, your first ML project, iris classifier. So let's say, how do we do that? We usually start small and practical. The iris dataset is it's a very public one. It's with UCI University, and it's publicly available. So how do we do that? Is you import it from load iris, train test split. You import that from that, and random forest classifier, and also the accuracy score. They are obviously like the data structure. They are like, the structure is 3 or 4 steps, which is, one is load data, the second one is the split data, third one is obviously test or train data, and then the last one is predict. Afterwards we need to take care of the score. So how do we load the data? It's just very normal function, which is like iris equal to load underscore iris. So this load iris where we have seen is over here. So the load iris, we will be just using it, right? And then coming to x comma y. So these are like the targets, or these are like the axis. The x-axis is the data, iris and dot data, and the y-axis is iris dot target, right? Now we have to split the data. How do we split the data? Is x underscore train, y x underscore test. Similarly, y underscore train and y underscore test. If you observe, x is in caps and y is in the lowercase. Next, train underscore test underscore split. This is again a library. Look over here, train underscore test underscore split, right? So that's where we import the library, and now we are calling the function, which is the x comma y test size. We will be giving the test size 0.2, and then as we have said, random underscore state equal to 42 or 0, whatever it is. Next is train model. So which is like CLF is the classification, as I said. So right now what we are using is the random forest classifier. So we are using this one. Now what we have to do is, so as I said, they are like 3 or 4, which is like fit, predicate and what was the other one? Score, I believe. So right now we are going to use the CLF dot fit. We are going to use x underscore train and y underscore train. This is because we are using the train model. Next, we will be predicting the model. How we'll be predicting the model is y underscore predict. We are going to declare a variable and we are going to say the CLF, which is the classifier dot predict of x underscore test, which we have put it over here, x underscore test. Now the accuracy is the most important thing, so that's where the score is being calculated. So what we are going to do is, the whatever the y underscore predict is there, we are going to say y underscore predict and y underscore test. So this is the y underscore test. Now with the scikit learning, understanding core concept is you have to start learning what happens behind the scenes. For example, what is classification, what is regression, what do you mean by features and labels, what is a train or test split, and where is the fit and predicate do. The projects which you can try are, for example, the iris flower classifier, which gives very good understanding of the classification, the house price predictor, which gives a very good understanding of the regression, the Titanic survival, which is again for the classification, handwritten digit recognition, MNIST, which is very famous, is for classification. The movie recommender system is for the unsupervised or the hybrid learner. Most of the scikit learning function will be covering under these 80% of them, right? So what are those? Train underscore test underscore split, which I have just seen, the library or the function. What it does basically, it splits the data for training and testing. Next is fit. It trains the model basically. Predict, obviously it says it is predicting the model. Accuracy underscore score, so that is where the whole meat of it is. It measures the performance. Next is pipeline. It chains pre-processing and model in just one shot. Okay. Learn common ML algorithm. So for example, we are going to explore different models. What are the different models? For example, classification, which is like the logistic regression, the random forest classifier, the SVC and all those stuff. Regression falls under few categories, which is like the linear regression, the decision tree regressive and all the stuff. Clustering means again the k means. Dimensionality reduction is the PCE. So what do you mean by the pipeline? Learn the ML pipeline flow in scikit-learn. So for example, instead of writing steps one by one, we have to learn how to combine the pre-processing, the model, evaluation, all the stuff. How do we do that is, we have to import pipeline, we have to import the standard scalar, the logistic regression and all the stuff. The syntax is again the pipeline, wherein we will be saying the scalar, which is the standard scalar. The first step is scale the data. The next is we have to train the model, right? So how do we train the model is, we will be using the logistic regression. And then this again follows the same, the fit, predict and the score. So pipeline dot fit of x underscore train and y underscore train, and y underscore predict is pipeline dot predict. Before we have seen the fit, now it's predict of x underscore test. Why this matters is, most of the real machine learning projects are structured like this, right? Now we have to practice module evaluation. Now don't just look at the accuracy, learn basically these. For example, the accuracy is the balanced classes, the precision recall is the imbalanced data, F1 score is wherein we will be trading off between the precision and the recall, which is like the imbalanced data. The confusion matrix is where we'll be visualizing the predictions, right? ROC, AUC is basically where the binary classification evaluation is. Learn feature engineering. So the most crucial thing in machine learning is, where is the missing value, the simple imputer, encoding text, one hot encoder, label encoder and all the stuff. Scaling is the standard scalar, min-max scalar and all the stuff. Polynomial features, the polynomial features, right? Selecting features is select k-based underscore RFE and all the stuff. Hyperparameter tuning is where is the use grid search to improve model performance. So we can use just the grid search, right? Wherein we'll be using the logistic regression, the params, and all the stuff. X underscore train and Y underscore train. This is the fit, and next comes the best parameter. So what is the best parameter? We'll be fitting that. There are few mini projects which you can try again. The spam email detector, which will give some understanding about the NLP classification. The credit card fraud is imbalanced binary classification and all the stuff, like, right. If you want to go much more deeper, you can master the pipelines, the pre-processing, and the EDA. You can also learn about the column transformer over here, which is very crucial. When to use the standard scalar versus the min max scalar and all the stuff. The EDA is with the pandas profiling or SweetWiz. Now comes the model selection and the cross validation. So with the same data set, you can use any number. I would say at least try 5+ models, which will give you a very good understanding about how the data set and the model works and all the stuff. And now we have to understand how to select the best model. Use cross validation score or stratified k-fold and all the stuff. Feature engineering and model tuning is use select k-best, RFE, the feature importance and all the stuff, right? Which is good. Tune hyperparameters with grid search CV and the randomized search CV, right? So that's where it's really good. Also get familiar with, for example, the joblib or the pickle, which will save your trained model, right? So whatever you have trained it for, if you want to save the model, you can use the joblib or the pickle. sklearn.metrics is where you can use the custom metrics and the ROC AUC curves. Imbalance learn for imbalanced data. Example, let's say if there's a fraud or something. And SHAP is you can use if you want to predict the machine learning model, right? So basically the goal is, first is the you have to load, clean, and transform obviously any data set. Next is you have to choose the right model. Depending upon whatever model you have to choose, and then evaluate properly. The next step is you have to build the machine learning pipelines. You have to tune the hyperparameters if there are any. Last, you have to upload well documented projects to GitHub. That's it. Thanks.